A satellite that a country relies on for early warning of a nuclear attack suddenly goes dark. The screen just drops to static. There's no explosion in orbit, no incoming missile, no debris field. So what happened? Was it a simple hardware malfunction, maybe a micrometeoroid strike? Or was it a deliberate act of war? In the vacuum of space, answering that question in time might actually be impossible. Welcome to This Explainer. Today, we're diving into a highly technical, strategic reality that defense experts are absolutely agonizing over right now. We're going to explore how a modern global conflict could easily begin and then rapidly escalate in orbit without a single physical shot ever being fired. We call it the anatomy of a silent space war. Okay, let's get into it. For decades, the public imagination has been totally captured by kinetic anti-satellite missiles. Weapons that blast a spacecraft into thousands of pieces of shrapnel. But creating a massive cloud of indiscriminate debris risks the Kessler syndrome. That's an unstoppable chain reaction of collisions that could just as easily destroy the attacker's own satellites. So the operational reality of modern counterspace warfare has decisively shifted away from that. We're now dealing with non-kinetic weapons. These are silent, they're invisible, they leave absolutely zero debris, and they are wrapped in a terrifying layer of ambiguity. And this lack of physical destruction? That is exactly why our orbital infrastructure is so uniquely vulnerable. Think about it. Modern civilization is completely reliant on satellites. We're talking GPS navigation, global financial transactions, military command and control, the whole shebang. Yet, as a recent U.S. Space Command workshop pointed out, there is no binding international treaty that clearly bans non-destructive attacks on these assets. So space is now contested in this really murky, highly unstable gray zone between competition and actual conflict. So what does this invisible arsenal actually look like? Well, there are 4 primary non-kinetic methods that states are deploying today. We've got electronic jamming, using radio frequency noise for denial and disruption. Then there's spoofing, which uses fake navigation signals for deception. Next is directed energy, using high-power lasers for dazzling or blinding. And finally, cyber attacks, network intrusions aimed at hijacking or data corruption. Let's break down the actual physics and logical mechanisms of how these disrupt a satellite without ever physically touching it. First up, we have jamming. Now, satellites are essentially just repeaters in the sky, right? They receive a weak signal from Earth and broadcast it back down. Jamming exploits this simply by blasting radio frequency noise at the exact same frequency as the legitimate signal. If the jammer's noise hits the satellite with more power, it just completely drowns out the real communication. It effectively deafens the satellite's uplink receiver. It is a reversible effect, but man, is it highly disruptive. But an even more insidious threat is spoofing. Instead of just blocking a signal with brute force noise, a spoofing transmitter generates a counterfeit navigation signal. It perfectly mimics a real GPS satellite, but, and here's the kicker, it feeds subtly modified false location or timing data to the receiver. This can trick aircraft, ships, or guided munitions into navigating entirely off course, all while their instruments are telling them that everything is completely normal. Then we move into the realm of directed energy. When a nation wants to hide its military movements from overhead spy satellites, they don't bother shooting the satellite down. Instead, they dazzle it. Using these incredibly sophisticated ground-based facilities, they shoot highly collimated, parallel beams of laser photons right up through the Earth's atmosphere. This floods the satellite's optical sensors with light, effectively blinding the camera and creating a temporary blind spot while it passes overhead. To really understand the sheer scale of these weapons, let's look at Russia's Kalina facility. This is a sophisticated ground-based pulsed infrared laser that operates at an immense energy density. We are talking 1,000 joules per square centimeter. To put that into perspective, that is 10,000 times more powerful than a laser used for retinal surgery. Focused through a multi-meter telescope, Kalina can literally shield an area of 100,000 square kilometers from optical intelligence collection. It's just massive. But the most vulnerable link in a space architecture is often sitting right here on the ground. Cyber counterspace operations specifically target the telemetry, tracking, and control networks. Attackers penetrate the perimeter, often exploiting vulnerable VPNs. Then they move laterally into the command networks and finally deliver their payload, like wiper malware. If you can corrupt the firmware of the ground terminals or the satellite's flight computer, you can permanently kill the system without launching a single physical weapon. Let's look at how this builds into real-world documented events. Because this absolutely isn't science fiction. It is an active global battlefield. According to the Secure World Foundation, at least 13 countries are now actively developing counterspace capabilities. Just look at the timeline. We saw the devastating 2022 Viasat-Kiasat hack that bricked tens of thousands of modems across Europe. Then massive Baltic aviation spoofing in 2024. And by 2026, severe network breaches into major organizations like the European Space Agency. And tragically, the human cost of all this is becoming very real. Back in December 2024, the strategic gray zone bled directly into civilian life. 38 people lost their lives in a commercial aviation crash over the Baltic region. The cause? A massive 500% spike in Russian ground-based GPS spoofing, emanating from bases in Kaliningrad and Pskov. It fed fatal counterfeit navigation data straight into the aircraft's systems. We're also seeing a rapid, real-time evolution in tactical electronic warfare. In Ukraine, commercial Starlink networks obviously became vital for drone navigation. In response, Russia deployed a mobile system known as the Volna Kupol Garant. Featuring an array of 8 antennas, this system specifically targets Starlink's uplink band, right between 14 and 14.5 gigahertz, effectively deafening the satellite receiver and suppressing drone operations over a 20-kilometer radius. But here's where it gets truly terrifying. The threat isn't just coming from the ground anymore. In a major escalation documented in 2026, researchers traced massive regional disruptions of the GPS L1 frequency band over Europe and Canada directly to orbit. It turns out Russia is utilizing 3 of its EKS missile warning satellites to broadcast electronic jamming signals straight down from space. They operate these high up and highly elliptical Molniya orbits, which allows them to hang continuously over specific regions. Section 1. The Co-orbital Menace. When physics masks intent. Imagine a small satellite slowly, quietly, maneuvering closer and closer to a multi-billion-dollar early warning satellite. This is what's known as a co-orbital proximity operation. The sheer danger here is that a hostile co-orbital satellite looks completely identical to an ordinary, harmless inspector satellite, right up until the exact moment it acts to physically interfere, jam, or intercept data. It gives defenders absolutely no clear warning sign. As the Center for Strategic and International Studies noted in their space threat assessment, Chinese and Russian satellites continue to display more and more advanced maneuvering capabilities, deeply alarming U.S. and allied officials. We are seeing coordinated, complex orbital dances. These are tactics, techniques, and procedures explicitly built for space warfighting, operating entirely in that murky gray zone where hostile intent is perfectly masked by basic physics. Section 2. The fog of war, the strategic danger of attribution. When a critical satellite suddenly stops transmitting, operators face an immediate, paralyzing crisis of attribution. Look at the difference. Was it a natural hazard? Did a solar flare fry the electronics? Did a piece of untracked micrometeoroid debris hit it? Or was it a hostile act? Was it painted by a directed energy laser from the ground? Hit by a cyber payload? Localized jamming? And if it was an attack, who actually pulled the trigger? This ambiguity isn't an accident. It is weaponized. It deliberately slows down defensive decision-making. I mean, if you aren't 100% sure an act of war just occurred, how can you possibly authorize a military response? This normalizes coercive gray zone behavior and creates a dangerous vacuum of international legal thresholds. When you combine this uncertainty with the immense strategic value of early warning satellites, you have a high risk of miscalculation and rapid, unintended escalation. It is a genuine powder keg. Section 3. Defending the void. Emerging countermeasures and the U.S. response. So how do militaries respond? Well, defense relies on speed and resilience. We're seeing systems like the AI-enabled Bounty Hunter, which provides space situational awareness by monitoring interference to detect hostile activity in seconds. Militaries are also shifting to highly distributed, resilient satellite constellations, making them much harder to wipe out in one go. Additionally, the U.S. has deployed countermeasures like the L3 Harris Meadowlands, a highly mobile, ground-based system that provides reversible, non-destructive defensive jamming to disrupt adversary links. But technology alone doesn't solve the strategic problem. As analysts have heavily emphasized, operating in this gray zone means that every lack of a meaningful response essentially sets a new norm for allowable behavior. Without clear, enforceable international laws and transparent attribution, adversaries are just going to continue pushing the boundaries of this invisible war. Which leaves us with this final, chilling question that defense experts are grappling with right now. Does ambiguity in space make conflict more likely to spiral out of control compared to traditional warfare? In a domain where an attack produces no sound, no explosion, and leaves no physical trace, does the very nature of this silent battlefield make catastrophic escalation inevitable? Think about that next time you look up at the night sky.